Speed, power, torque, and DC motors. The unit objectives. The students will be able to demonstrate the concept of speed. Students will be able to demonstrate the concept of power. Students will be able to demonstrate the concept of torque. Students will be able to describe the four primary characteristics of a DC motor and how they relate to each other. And the students will be able to calculate motor loading for a mechanical DC motor system and describe how changes in the system would affect the loading. Speed, power, torque, and DC motors introduction. Engineering is problem solving. Engineering is the application of practical and scientific knowledge to a methodical problem solving process. Distance versus displacement. Distance is the quantity that has no direction and refers to the length a moving object is covered. Displacement is a quantity that has direction. It refers to an object's overall change in position. Classical mechanics and terms. The field of classical mechanics deals with the study of bodies in motion, specifically the physical laws that govern bodies under the influence of forces. Speed, a measure of how fast an object is moving, or how far an object will travel over a given period of time. Speed equals distance divided by time. Speed is measured in meters per second. Rotational speed. Speed can also be expressed rotationally. This refers to how fast something is moving in a circle. Rotational speed equals degrees over time. Rotational speed is calculated using rotational cycles over time. It's measured in units of degrees per second or rotation cycles per second. Acceleration. A change in speed over a period of time. The higher the acceleration, the faster the change in speed. Acceleration is the rate of change of speed. Acceleration equals speed divided by time, and it's measured in meters per second squared. Force. Accelerations are caused by forces. They are influences that change movement, direction, or shape. Force is measured in newtons. Torque. Force directed in a circle, causing or rotating an object. Torque equals force times distance. Force can also be equal to the torque divided by the wheel radius. Work. The measure or force exerted over a distance. Work can also be thought of as a change in energy. Work equals force times distance, and it's measured in Newton meters or joules. Power. The rate that work is performed. How fast can someone do their work? Power equals work divided by time, and it's measured in joules per second. DC motors. Actuators are mechanisms used to act upon an environment. Actuators drive everything that moves on a robot. The most common type of actuator in this application is a motor. Motors convert electrical energy into mechanical energy through the use of electromagnetic fields and rotating wire coils. When a voltage is applied to a motor, it outputs a fixed amount of mechanical power. The mechanical power is the motor's output, spinning at some speed with some amount of torque. Motor loading. Motors only apply torque in response to loading. The higher the load placed on the motor output, the more the motor will fight back with an opposing torque. The more torque the motor outputs, the slower its rotational speed. The more work one makes the motor do, the slower it spins. If one keeps increasing the load on the motor, eventually the load overcomes the motor and it stops spinning. This is called a stall. Current draw. The motor draws a certain amount of electrical current, expressed in amps, depending on how much load is placed on it. As the load increases on the motor, the more torque the motor outputs to overcome it, and the more current the motor draws. Key motor characteristics. All motors are different, and their properties vary depending on their type, configuration, and manufacture. There are four main characteristics that govern the types of DC motors used commonly in robotics. Stall torque, the amount of load placed on a motor that will cause it to stop moving. Free speed, the maximum rotational speed a motor will run at when it is under no load. Stall current, the amount of current a motor will draw when it is stalled. And free current, the amount of current a motor will draw when there is under no load. Varying power with voltage. If a motor is under a fixed amount of load and the voltage is increased, it will spin faster. This means that the motor characteristics change depending on the voltage applied to the motor, and as such they need to be listed at a given voltage. Motor limits and calculations. Motors have limits. At some point, the power will be too much for the motor's electrical windings to handle and it will fail. This doesn't happen with VEX motors. They all have internal thermal breakers that cut the current being delivered to the motor if they get too hot. This is good because it means the motors won't burn out, but it presents a new constraint for designers, making sure the motors don't trip the breakers. How do designers do this? By designing systems so that the motor doesn't draw more current than a specified amount by limiting the amount of load that will be applied. Arm design. It is possible a designer would use an arm to pick up objects and them in a goal. Simulate and size a DC motor. Go to this link, I'll put the link in the description. Watch and take notes over the overview, video 1, video 2, and the summary, and then come back to this and finish watching this video. Formulas. Motor key specs: stall torque, free speed, stall current, and free current. Please answer the following in your engineering notebook. Why would you want to increase your speed and lower your power? Why would you want to increase your power and lower your speed? How does that change in the load affect How does the change in the load affect your current draw?